In this episode, we are going to look at multinomial logistic regression analysis in Stata. This type of regression is simply an extension of binary logistic regression. Unlike in binary logistic regression where our outcome is categorical with only two levels, multinomial logistic regression allows you to analyze a categorical outcome with more than two levels, 3 and above. Here is our hypothetical data set that we are going to use to demonstrate this multinomial logistic regression in Stata. We have our outcome variable, which is the method of contraceptive used. Either someone used short-term contraception or long-term, or someone did not use a contraceptive at all. So there are 3 levels. We also have 4 independent variables that we want to use to predict which contraceptive method did someone use. By looking at our outcome, it is coded as 0 for no contraceptive used, 1 for short-term contraceptive used, and 2 for long-term contraceptive used. The way your outcome is coded is very important for our subsequent steps. So to run the multinomial logistic regression analysis, simply go to statistics, categorical outcomes, and then multinomial logistic regression. In this dialog box, we specify our categorical dependent variable with at least 3 levels. That is our contraceptive method used. And then our independent variables. We have here age, number of children, and then marital status, then residence. But these 2 variables, marital status and residence, are categorical predictors. So we can tell Stata that they are categorical by using the 3 dots, and then we leave factor variable checked and their main effects. Then we specify the variable marital status, add it to the variable list. We do the same for residence. We add it to the variable list and click OK. Then here you can see that we have I dot before the variable name, indicating to Stata that this is a categorical variable. They will create dummy variables for it. So I'll check this box and specify that I want my outcome category coded 0, the one of no contraceptive used, as the reference category. And then under reporting, I want to report relative risk ratios, and click OK. Here is our output for the multinomial logistic regression. We have the iterations here. We have the test about the model, and then we have our parameter estimates. You can see that in this table, it is divided mainly into 2 main parts. We have a part for the short-term contraceptive used and a part for long-term contraceptive used. Then you notice that no contraceptive used is being used as the base outcome or the reference category. So short-term contraceptive use is being compared to no contraceptive. Similarly, long-term contraceptive use is being compared to the no contraceptive used. So now let's interpret this output using our PowerPoint here. So the first part of our model was looking like this. It has the iterations, and then we can see that we have a total of 150 observations. The likelihood ratio chi-square at 8 degrees of freedom has a value of 17.99 with a p-value of 0.012. Then the pseudo R squared of 0.0746. From this model, our p-value of 0.02, it is less than 0.05, the usual alpha value, shows that there is a statistically significant difference in the model having our predictors, the one we fit, compared to the null model in predicting our outcome. Then the pseudo R squared indicates how much variation in the dependent variable can be explained by the independent variables in the model. However, interpretation of this R squared value should be done cautiously because it is not equivalent to the R squared we would get from the linear regression model. Then we have our table having the parameters, which is divided into the one for short-term contraceptive used and long-term contraceptive used. So let us first focus on this first part of short-term contraceptive used being compared to no contraceptive used. So we have our outcome variable, contraceptive used, and then the different independent variables at the different levels of the outcome. We have the relative risk ratio, their standard errors, the Z values, and the corresponding p-values, then the population 95% confidence interval. So the interpretation of the relative risk ratios will be a bit different for numeric variables and the categorical variables. So let us start with interpreting the categorical variables first. During interpretation, we have to first understand that we are going to have two comparisons. There is a comparison of one level of outcome compared to the other, and then there is a comparison of one level of independent variable compared to the other. For example, when we talk about marital status, we are looking at married people compared to single people. At the same time, short-term contraceptive use compared to no contraceptive use. So those are the two comparisons we are using. So if we are to interpret marital status, the relative risk ratio, the results indicate that married people compared to the single ones are more likely to use short-term contraceptives after controlling for age, number of children, and residence, and this association is statistically significant. So this group, compared to singles, are more likely to use short-term contraceptive instead of no contraceptive used. Another categorical variable like residence, we can see that for it is non-significant. Residence, being in urban compared to being in rural setting, is not significantly associated with short-term contraceptive use after controlling for age, number of children, and marital status. Then you can see the estimates here in brackets and their 95% confidence interval. So the key point here, when you are interpreting a categorical variable, you're making two comparisons. Comparison within the independent variable and comparison between the levels of the outcome. When it comes to a numeric key variable, for example, age here, a relative risk ratio which is greater than 1 indicates an increased likelihood of the response category, in this case, short-term contract, compared to the reference category or the no contraceptive. In other words, these results show that with increase in age, it is significantly more likely to receive short-term contraceptive after adjusting for age, number of children, and residence, and this association is statistically significant. That's what it basically means. A similar interpretation for children, which is numerical, although here it is non-significant, so don't bother to interpret it. We now shift our focus to this second part of the table, which is comparing long-term contraceptive use to no contraceptive use. So the interpretations are similar to the ones we've just done. For example, here, when we look at the p-values in this column, we can see that only marital status is statistically significant, and it is for a categorical variable where married people are being compared to the single people. So these results show that only marital status, being married in particular, is significantly associated with using long-term contraceptives after adjusting for age, number of children, and residence. If you found this video useful, consider liking and subscribing to the channel so that you don't miss out on any of our episodes. Next, we are going to look at ordinal logistic regression. See you in the next episode.